All right, welcome for our final lesson of the week. We're going to start with this warm-up that says to algebraically calculate the inverse of the function f of x equals 3 to the x power. So just take maybe 2 minutes to try to do that on your own, and then when you're ready, unpause the video and come back. You do not need to know how to do this yet, but try your best and see what happens. So if you tried it, the first thing we're going to do, how we always start these, is to switch x and y. So we're going to have x equals 3 to the y power. And once we get there, we need to solve for y. And the problem you most likely ran into is how do we get that exponent down in front? Like what do we do to get this y so we can solve for it? If we divide by 3, that really isn't something you can do mathematically to get rid of the 3. So we don't quite know how to do this yet. So today we're going to explore a strategy on how can we calculate that inverse. What can we do mathematically? So we're going to start by just looking at that 3 to the x. And we're going to first find the inverse just using a table and a graph. So the first thing we're going to do is we're going to fill in the table for f of x. So for x is negative 3, we have 3 to the negative third power, which is 1/3 times 1/3 times 1/3, which gives us 1/27. So a really small number. For 0, we get 3 to the 0 power, which is just 1. We get 3 to the first power, which is 3. And you can't quite see it on yours, but that's a 2 right there. And so we get 3 to the second power. 3 times 3 gets us 9. So we're just going to graph those points. So negative 3, 1/27, 0, 1, 1, 3, and 2, 9. So you get this exponential graph, and that graph gets really close to 0 but never quite touches it. So it asks us what's the domain and range. So if you remember all the way back to our first unit where we talked about domain and range, domain is what's the possible x values. Well, you can see our arrow is going to go on forever both ways. So domain for the x values is all real numbers. X can be any number. But for y, what's our limit on our y? What's our possible y values? Well, can y ever be 0? Will this line ever touch? If we keep dividing by 3, dividing by 3, dividing by 3, is that ever going to touch that line? Not quite. So our range is y is greater than 0. It can be any number above 0, but never get to 0 and never go negative. So we're going to now look at the inverse of that function. So we're going to, it says, use our table from part A to fill in the table for the inverse. Since we don't have a smartboard here, we're just going to do that up top. So what that means is we're going to make a new table for the inverse of it. So we have x and f inverse of x. So instead of negative 3, 1/27th, 1/27th, negative 3, 1, 0, 3, 1, 9, 2. And we're going to graph that on the same graph. So when x is just a little bit big, we get this negative 3 value. When x is 1, y is 0. When x is 3, y is 1. And when x is 9, y is 2. So you get this sort of, it kind of looks like a butterfly shape. Kind of reminds us of our rational functions, but it's a similar butterfly shape where it's reflected over that line. So that's the inverse of 3 to the x power. But what's our equation for that? We don't quite know yet. We're going to have to explore that a little bit more. And then it says, do they appear to have some graphical relationship? And is it a function? So we want to say, is this a function? And it would be a function because it passes the vertical line test. For each x value, there's only one y value. And then the next question, the last part, asks, what is f inverse of 81? Explain your reasoning. So to do that, we're going to start by, let's just make our table. Well, let's make our regular table because that's a little easier to deal with. X and f of x. So we went 0, 1, 2, 3. So we went 1, 3, 9, multiplying by 3, 27. And 4 gave us 81. So if we flip those, 81 would give us 4. So our answer, f inverse of 81, gives us an answer of 4. So we have this problem. How do we solve x equals 3 to the y power to get the inverse? How do we do that? We saw a graph of what it would look like, but we don't know how to actually write an equation for that graph yet. So this is called the ancient puzzle. So parts A through F below are similar to a puzzle that's more than 2,100 years old. Mathematicians first created the puzzle in ancient India in 2nd century BC. More recently, about 700 years ago, Muslim mathematicians created the first tables, allowing them to find answers to this type of puzzle quickly. Tables similar to them appeared in school math books until recently. So here are some clues to help you figure out how the puzzle works. So what we're going to do here is I'm going to give you these 4 examples, and then you're going to try to find out what's the question marks in the rest of them. So there's this new word, log. Log, and that's read log base 2 of 8 equals 3. So I want you to actually take about 5 to 10 minutes, pause the video, and try to figure out what these question marks are for this puzzle. So 5 to 10 minutes, and unpause when you're ready. So if you don't have the pattern down yet, or you do and you're feeling confident, good job. If you got a couple right, nice job. All I care about is you tried something. All right, so the definition of a logarithm, this is the most important thing you're going to learn, and this is going to be crucial for everything going forward. This is something you have to memorize. So what we're saying here is if we have some number b to the y power equals x, just like our warm-up problem that we were exploring, that means that then log, and this is log base b of x equals y. This is the definition of a logarithm. I'm going to write that a little better. Log base b of x equals y. So what this is saying, if you go back to our previous puzzle, what this is saying is, just on the most basic standpoint, what a log is it's saying this means this is 3 to the 2nd power equals 8. 5, this to that power equals that middle number. 5 to the 2nd power equals 25. So how I got 4 here is I said 2 to what power equals 16. I changed it from, in our next one, in the definition of log, I went from log back to an exponent. Here, 2 to what power gives us 32. Here, our question mark is the log. What to the 2nd power equals 100. Here we have 5 to the 3rd power equals question mark. And the bottom 2 we've already covered, similar examples, so you can finish those. But that's what a logarithm is. That's the definition of a logarithm. So we're going to use that to solve some algebra. So to summarize our thinking, we're going to find the missing value. So if we're using, I'm going to write this up in the top right corner just to keep it. It was b to the y equals x, then log base b of x equals y. So we're going to go now. We're going to start with this and change it back to this form. So let's first identify b, x, and y. So b here is, well, it's log base b. This is log base 7. X is what's inside the parentheses. So here it's 49. And y in this is an equals question mark, so we don't know what y is. So we're going to change this back to this form. So we're going to have 7 to the question to what power, or to the y, you can also write a y there, equals 49. And from there, we can say, well, 7 to the second power gives us 49. So pause the video, and I want you to rewrite all 4 of these into this exponent form and solve for the missing variable there. So when you're ready, unpause and check your answers. All right, so here's what I got. So make sure you can do this second one because that's super important. It's the most important one. And then here, 4 to what power equals 0? There's no solution. There's no amount of times you can multiply or divide by 4. You can never get 0. We say no solution. And then this bottom one, you have to realize 1/25 is actually 1 divided by 5 squared. So we get -2 there because 25 squared, or 5 squared is 25. So 1/25 would be dividing by it twice. That's why it's a negative. So now wrapping it all back to what we started with, we're going to algebraically calculate the inverse of that warm-up problem. So first we're going to say x equals 3 to the y power. So we're going to start off with x, well, x equals x, y equals y, and b in this case is 3. So we can rewrite this as log base 3 of x equals y. That is the equation of that curve we graphed, and that's the equation of the inverse. So just using that rewriting skill like we did. All right, so to close out today's lesson, we have some four problems to do right here. So we'll do the first A and A together, and then B and B will be your homework to submit. So this first one, we want to find, algebraically calculate the inverse. So we're going to switch x and y. So we have x equals 4 to the y power. And we're going to write x, well here, x equals x, y equals y, and b equals 4. So how we're solving this is we say log base 4 of x equals y. So that's for 1A. Try 1B on your own. That's your homework to submit. And then for the second problem, we're going to solve, and it says leave your answer in terms of a logarithm. So you don't need to use a calculator or anything to find the exact answer. So we're going to start by here, 9 times 7 to the x equals 54. So first step, divide both sides by 9. 7 to the x power equals 54 divided by 9 is 6. And here's where we're labeling our A, B, x, y, and b. So x here is x. It's actually x here, b to the y equals x. b to the y equals x. So our x here is 6. Our b here is 7. And our y, in this equation, our y is x. So how we rewrite that is log base 7 of 6 equals x. And we just solved for that x right there. So you're going to, for homework, do 1b and 2b as well. That's all I have. Thanks for joining us. I will see you next week.